Now, when using logs to solve equations, the following properties are all really important. The last three actually were used in the production of slide rules, which for about 100 years were what people did when they made scientific calculations of any kind. The first two we will use very often just to make something very simple. The last one we'll use every time we try to solve an exponential equation. The middle two are the ones that actually really help people do calculations for 100 years. And you'll use them occasionally. Now and then they can actually make something simple. But the first two we use a lot to make something simpler. The last one is the ones we use to solve equations. And the middle two historically are really important, and occasionally they can help. Now what I'm going to do is just go through these one by one. So we're going to get rid of these, as the first two actually go together. And I want to talk about why each of these is true. The first one is really kind of silly, because that's just the definition of logarithm. If I want to take log base a of something, I'm supposed to take the thing inside the parentheses. I'm supposed to write it as a to the x, and then the answer is just the exponent. Well, all that says is exactly what we just said. It's already written like a to the x, and the logarithm, all it does then is just give us the exponent. So the very first one, it really is just the definition of logarithm. The second one, if you really want to understand it right, you think in terms of inverses of functions. Because what we have is we have a function, an exponential function, a to the x, and we have its inverse function, g of x. And we write it as log base a of x. Now remember what the definition of an inverse function is. It's got two pieces. It says that whatever evil stuff g did to x, when you do f to it, you get x back. So that really means they undo each other. The second part of that says whatever f does to x, g perfectly undoes it, and you get x back like that. Now, if I look at this and I want f of g of x, f of g of x, go like this. So f of g of x, and we know they're inverse functions, so in the end they're going to get x. F of g of x, what am I supposed to do? I'm supposed to take g of x and put it in for x. That's just going to be a to the log base a of x, like that. And since they're inverse functions, you get x. We can do this with words as well. Remember what log base a of x is. It's the number you have to raise a to in order to get x. This number right here is the number you have to raise a to in order to get x. So when you raise a to it, you get x. That sounds a little weird. Actually, because it's so simple, we can't think of these as being inverse functions. We can work our way through it. But again, working our way through it is going to feel like the other two, but at least we'll have worked our way through it. Now, how do we work our way through it? Let's start on the left-hand side. In order to calculate log base a of x, we're supposed to write x as a to some power. So here what we're going to do is we're just going to write x as a to some power. I don't know what the power is. I do know there's a power that works. So what I'm going to do is say a to the log base a of x, right? And inside the x, I'm going to put as a to some power. So this is going to be a to the log base a of a to the b. Well, let's look at this part right here. The log base a of a to the b is just b. So what I'm going to get is just a to the b. What's a to the b? Well, we have it right here. It's just x. So we can do this with inverse functions. We can do this with the definition of logarithm. We can do this just by working our way through it. But it is a property that we will use over and over and over. So, and in the end, we're going to have a feel for it. So try to figure out a way to think of it where it doesn't freak you out. All right, now let's go through the three magical properties. These are the ones that get used when we're solving exponential equations or logarithm equations. And here's the first big one. I guess this is actually equation number 3 on my list, so I should call it 3. It said that log base A of xy equals log base A of x plus log base A of y. Now, how are we supposed to think of this? Well, not the way we're going to show it and not the way we're going to use it. But the idea is when you're multiplying two things together that both have the same base and look at the exponent, what do? You add the exponents. That's the right way to think of this. If you need some practice or a lot of practice to get there, let's get there. But that's actually what's going on. When you multiply two numbers together that have the same base, what do you do with the exponent? Because that's what this is asking for. It's the exponent of the first one plus the exponent of the second. Now, if that's too much, this is what we're going to do. If I want to take the logarithm of some number, I need to write that number as x to some power. I'm sorry, as a to some power. So what I'm going to do is I'm going to say, let's write x as a to the b, and we'll write y as a to the c, like that. And we're just going to start from the left-hand side and see if we can't just work our way through it. Starting from the left-hand side. So I'm going to get log base A of xy. I know what x is, I know what y is. This is going to be log base A of a to the b times a to the c. And this is where what I just said comes into play. When you multiply two numbers together, to get with the same base, you add the exponents. So I'm going to use that rule of exponents, and I'm going to write down the log a. This is going to be a to the b plus c, like that. And now we've written the inside as a to a power, and so we're just going to get b plus c, like that. Now we do need to figure out what b and c are. And we talked about this yesterday, that if x is a to the b, then the log base a of x is just b. The log base a of y is just c. And we're going to get down here, let's see, twisty like that. I'm going to get the log base a of x plus the log base a of y. Just like that. Okay, so that's property number 1. The log of a product is equal to the sum of the logs. We're going to do the next one. We'll try to set this one up just a little bit differently, so you can take your pick about which way you felt better about it. Okay, magic property number 2, which is number 4 in our list. The log base a of a fraction equals the log of the top minus the log of the bottom. Like that. Ta-da! Now, the way I said this before is exactly right. What does this ask us to do? It says write x as a to a power, write y as a b to a power, and then look at the exponent. Well, that should just be the exponent on top minus the exponent on the bottom. That's exactly right. So we're going to start this off the same way we did before. I'm going to write x as a to some power. Okay, how about b? Y as a to a different power. Let's say c. Now, just a reminder here that what does this mean? This tells us here that if I want to take the log a of x, that's going to be the log base a of a to the b, and that's just b. Now, that's something we actually said yesterday, that if you write down x equals a to the b, that's the same thing as saying log base a of x equals b. I think I did the little song thing, right, where I went a to the b equals x, yes, and the same thing is going to happen here. We're going to get the log base a of y equals c, and again, just checking this, a to the c equals y, yes, all right. Now what I'm going to do is I'm just going to work out the log on the left-hand side. So I want the log of the fraction. Well, I'm going to write x as a to the b and y as a to the c. So this is going to be log base a. I have a to the b on top. I have a to the c on the bottom. And this is the rule of exponents I said came into play. How do rules of exponents go? When you're dividing two numbers with the same base, you subtract exponents. So this is going to be log base a of a to the b minus c. Well, how does log work? Log says write what's on the inside as a to a power, and the answer then is just the power like that. But b is the log a of x. And c is just the log base a of y. Like that. And so we get our second property. That the log of a fraction is what you get when you take the log of the top minus log of the bottom. But you can see in the middle, that was just the same law of exponents that we've always been using. The last magic rule is the one that we use more often than any other when we're solving exponential equations, because it's the one that we're going to use when we try to get the x out of the variable. I'm sorry, the x out of the exponent. Let's see here, I'm trying to get here over like this. This is the last property we have. It is the third magical property because it gets just used like crazy. What it tells us is that the log base a of x to any power, it says you can bring down the power. This actually shows up in calculus in a really funny place where no one expects it. So even though we use it to solve exponential equations, it's going to show up a lot. Now what I want to do is start on the left side. We'll start on the left-hand side. And what I'm going to do is start out the way we did before. I'm going to write x as a to a power because log is going to require that. Remember, that's exactly the same as saying that the log base a of x equals b. And I can check that by going a to the b equals x. Okay, now once I've decided that x equals ab is a good thing to write, I'm going to write the log a of x to the m, because that's what we're trying to figure out. I'm going to put a to the b in there. This is log base a of a to the b to the m, like that. Well, we know what, again, this is the rule of exponents. When I take a number to a power, we multiply the powers. So what this is going to give me is log base a of a, I guess this is going to be m times b. We'll put a little m times b like that. Now what am I supposed to do now? Well, what does log say? It says write what's inside is a to a power, already done, and the answer then is just going to be the power. So then I put the power. Yay! Well, why does that mean I'm done? Because b is the log base a of x. So I'm going to write down m times log base a of x, and that's the third property. That's the one we're going to use lots and lots, but you can see that just came from a rule of exponents too. It's just a very weird way of writing that last rule of exponents, and for solving exponential equations, this is the one we're going to have to use.